in example 4, if we distribute the natural log of x, we'd get 3x natural log of x plus natural log of x, and you would still have to do the power rule after distributing. So whenever you have multiplication of two functions where neither one's just a constant, both of them have x involved, you can use the product rule. And if that's the case, well, you do the derivative of one multiplied by keeping the other one the same, then you keep the other one the same and do the derivative of the other one. We've been color coding it as we've gone, right? And I've always color coded the first one yellow and the second one green. So when doing the derivative, well, we keep one of them the same, the first, oh my goodness, almost disaster. Keep the first one the same, derivative of the second one. Remember, the derivative of natural log is 1 over x. And then we keep the second one the same, times by the derivative of the first one. So each of these in example 4, it doesn't actually help to distribute first and then try to find the derivative, because you'd have to use the product rule anyways. So we may as well just use the product rules to begin with. And for the most part in these questions, you're not asked to simplify afterward. So we just do this one step of doing the product rule, and we'd leave our answer like this. I mean, you could distribute the 1 over x and get 3 plus 1 over x if you'd like, but you wouldn't need to. Often in an answer key in the textbook, they do have it simplified. So you might have to change it after that if you're checking your answers. But for the most part, this is all you need to do. So I want you to try the next two, just sort of as a warm-up to help us review the product rule. Help us review some of our new functions that we found derivatives, like what's the derivative of tan? All right, so if you want to check B and C, I'll put up here as well. And the last one, keep one the same derivative of the other, and then keep the other one the same derivative of the first. This one said simplify, so you'd have to multiply everything out, combine your like terms, and this is what you would get. Now in this situation, and I'm going to do it in blue, what happens if we simplified first? So I'm going to distribute the 2x. That would give me 2x to the 5 plus 6x to the 4 plus 12x. And then I'm going to distribute the 1 plus x to the 4 plus 3, or the minus 1, sorry. So it'll be minus x to the 4 minus 3x cubed minus 6. So I could distribute first, and then I could combine my like terms to get 2x to the 5 plus 5x to the 4 minus 3x cubed plus 12x minus 6. Now if we found the derivative directly from this, it's just power rules. It still took me 3 lines. Whether I simplified first or I took the product rule first. So in this situation, I probably just would do the product rule first. But I guess it really doesn't matter. It's about the same amount of work whether you simplify first and then take your derivative, or take your derivative first and then simplify afterwards. Yep. So we've got g of x equals 2x sine x. How do we know that we have to use the product rule? I like adding the multiplication. It's 2x times sine x. In my multiplication, can you see that there's an x in your first term and there's an x in the second one? That's telling you you're going to have to use your product rule. So how do we do our product rule? We keep one the same, derivative of the second one. Then we keep the second one the same, derivative of the first one. Find the gradient of the graph of g at pi. So remember, when we find our derivative is a gradient function. It's finding the slopes of all the tangents at any particular point. If you want to find the slope of the tangent at a particular point, like at x equals pi, you take your derivative equation and plug in pi. I know it's been a while. How are your unit circle skills? Apprehensive breathing. Okay. Cos of pi? -1 sine of pi? Excellent. And so the slope is just -2 pi. And then, of course, this question could say, find the equation of the tangent line at x equals pi. And then you'd have to find a point and a slope to do that. Last question in this section. Do we have the product rule? Well, we've got two things multiplied right there. Both have x in them. So yes, we're going to have the product rule. So find the derivative first. Keep one the same, derivative of the second. Then keep the second one the same, derivative of the first. Now, after taking the derivative, I noticed here that I have a common factor of e to the x. So I could factor that out. You wouldn't have to, but when doing that, just might make life a little bit easier when simplifying. When you plug in pi, well, sine of pi is 0, and cos of pi is -1. And so the derivative just becomes -e to the pi. That would be the slope of our tangent line. So if that's the slope of our tangent line, what's the slope of our normal line? 1 over that. And becomes positive, because the slope of your normal is the negative reciprocal. Just feels a little bit weird when your negative reciprocal is like a power to begin with and not a fraction, right? But you can just make 1 over what you have to do the reciprocal.